But what are hyperbolic functions? So hyperbolic functions are just like trig functions, except that they're not on the unit circle. They're defined to be using hyperbolas. So if you take a look at this picture, our hyperbolic functions are going to be defined by looking at any point on the two parabolas we have. So this one or this one, which very much like trig functions, any point that we have here on our hyperbola will correspond to cosine and sine of that particular angle made by any point on the parabola to the origin. Okay, so if you notice, and I definitely have this out here. So for this particular point that we have here, the angle would be theta over 2. Okay, and very much like our trig functions, we have that x is our cosine and our y would be our sine. Again, we don't really work too much with hyperbolic functions right now, but you do see them in other topics and sections in math. Now, sine, cosine, tangent are all defined over here on the left side. So it turns out that sine h of x is e to the x minus e to the negative x over 2. Cosine hx is e to the x plus, that's definitely a plus sign here, plus sign, e to the negative x, and then tangent is going to be defined by sine tan h. It's going to be defined as sine h over cos h. And then you have cosecant h, secant h, and cotangent h defined by its reciprocal function. Of our hyperbolic functions, again, the graphs here do look a little bit like parabola for cosine. You have the graph of sine, and you have the graph of tangent. Okay, and then what we're working on in this section is looking at the hyperbolic identities. Again, these come very much like trig. So we already have how negatives affect our function. If we have a negative inside of sine, then the whole function is negative. If we have a negative inside of cosine, then our function continues to stay positive because it's an even function. Then we have our Pythagorean identity. So cosine squared of x, cosine h squared of x minus sine squared of h is equal to 1. Same thing with the tangent and secant situation. And then we have the sum of sine h and the cosine h, sum of cosine h that we're going to have to use. And then what we're interested in, which is the derivative of the hyperbolic functions. So very much expected. The derivative of sine h of x is cosine h of x. The derivative of cosine h of x is sine h of x. Derivative of tangent of h of x is secant h squared of x, and we know the other 3 as well. Okay, so again, this is what you may need to add onto your list of derivatives. Now, on the day of the test, you will get a full list, but as you're kind of using this to study, you can definitely add this to our list. Okay, so here we're just going to evaluate the following hyperbolic functions at some value, and if possible, we can round our answers to 5 decimal places. So sine h of 0, and we're going to use the definition of sine h of x, which is that ex minus e negative x divided by 2. Well, we know any to the 0 power is 1. So we end up with 1 minus 1 over 2, which gives us a 0 over 2. So sine h of 0 does happen to equal 0. So we can do the same for cosine of h. So we end up with e to the 0 minus, oh no, this one is plus e to the negative 0. Here's my thumb. Oh my gosh. Get out of there. Nah. This is not a water bowl. So again, we can use the definition of cosine h of 0, which is very much similar to sine h, except that of a minus, and we have a plus sign. So with e to the 0 plus e to the negative 0, which is still 1. So 1 is equal to 2, and we end up with over 2, which is definitely equal to 1. Do the same thing here with cosine h of ln of 4. So we have e to the ln of 4 plus e to the negative ln of 4, not x, sorry about that. All over 2. Well, we know that e and ln cancel out, so we end up with 4 minus 4 is equal to 2. Therefore, we end up with 0 over 2, just do 0. This is cosine of 4. And we have e to the 4th plus e to the 4th 2, which puts us at 2 e to the 4th over 2, which is definitely just e to the 4th, and then we can use our fancy calculators to find the decimal approximation of e to the 4th. And again, based on the instructions here, we want to go to 5 decimal places. So e to the 4th is actually 54.59815. That's our solution there. Now we have secant h of 0. And again, we're just using the definition of given to us on the first page, that secant is the same as 1 over cosine h of 0. We actually already know what cosine h of 0 happens to be 1. So it's just 1 over, which is 1. Now, again, you could have gone through the process of putting this in, but we didn't really have to do all that since we already know what cosine of h is. Cosine h of 0 happens to be. Cosine h inverse of 1. So this is going to be the same thing as cosine h of 1 to the negative 1 power. So we'll actually work that out. So that would now be e to the 1st plus e to the 1st all over 2 to the negative 1. So we end up with 2e over 2 to the negative 1. But that's just e to the negative 1, which is 1 over e. And there we have that. Okay. So those are just some of the questions that you'll look at in this section. And then we're going to go on to verifying identities and then using our derivative rules to find some nice derivatives. I don't know if I'm going to go through all of these. You will have 1 or 2 on the exam. But these are not terrible. Again, you're using either the definition of what cosine and sine are, or at the very most, you would be using one of the hyperbolic identities to rewrite some of these. This one's really nice because this is just taking the definition of cosine h and sine h and hoping that you end up with e to the x, which is possible because, again, cosine h is going to be e to the x plus e to the negative x over 2 plus sine h, which is the x, minus e to the negative x over 2. And I know that they have the same denominator, so we can actually put those together. So we have x plus e to the x plus e to the negative x. Sorry about that. My attentiveness always seems to get in the way. Minus e to the negative x. So again, we are putting these together and these together. And we know that second one has a negative sign, so that's going to cancel out. And we end up with 2 e to the x. Again, this will go to 0, or not go to 0, it actually ends up being 0. And as expected, we end up with e to the x. Not bad. Okay, so that's sort of the big sort of picture. You need to be working with the definitions of cosine h and sine h, and then again verifying these. Let's take a look at our next page here. Here's a fancy one where you are definitely going to use the hyperbolic identities for the sum. So we have that the sine h of x plus y is equal to sine hx times cosine h of y plus cosine h of x plus sine h of y, which again is the actual identity, so we're not going to use it because that's just, we're proving this actual identity. We're going to use the definition of sine h and cosine h to see if we can come up. I'm going to go with the right side here because obviously, I mean, either way, you're going to end up somewhere, but the left-hand side, usually the harder side is the one that you started with, which in this case, it looks to me to be the right hand. So we have sine h of x times cosine h of y plus sine h of x and h of y can be rewritten as e to the x minus e to the negative x all over 2. So this piece here happens to be this right there. And then we can look at cosine, our next one. So times e to the x plus e to the negative x all over 2. So that's, again, this green piece. And then to that, we are adding... Oh, I definitely forgot that these were y's. Oh, no. So it's cosine h of y. So there. And then what we're doing on this one, cosine x. So we have e to the x plus e to the negative x over 2. And that comes from, you guys know I love the color here. So that one is this one. And then we're left with sine h of y, which is e to y minus e to negative y over 2. And that's going to be the last one that we rewrite. So then hopefully rewriting it out this way gets us somewhere. Let's see, what can we do here? We can definitely add these together because they all have the same denominator. However, maybe we can work through multiplying some of these through. So if we take a look at the first two fractions, it'll be over 4 and e to the x minus e to the negative x times e to the y plus e to the negative 1. Let's see what happens when we multiply this through. So when we multiply a base, same base, and that has exponents, we actually add the exponents. So this would turn out to be e to x each plus, again, so that's going to be going, let me change the color. What fun color should we use? Okay, this one looks fun. So this would be e to the x plus y. That one would be e to the x minus y. And then we take these, which that would be minus e to the negative x plus y. And then one last time here, we end with e plus e to the negative x minus y. Whew, that's a little bit crazy, but it's not bad. All divided by 4. And then we're going to do the same thing here. So we still multiply these together, and we're going to take the x plus e to the negative x times e to the y plus e to the negative y, which will actually be the same exact thing. So we'll just rewrite that. So e to the x plus y plus e to the x minus y. And I said it and wrote something else. Minus e, so negative x plus y plus e, so negative x minus y. Or 4. Now I can attempt to put together. So we have how do we put these together? Let's see. We have this one. So that's going to be 2e to the x plus y. Then we also have this one with this, so that's going to be plus 2e to the x minus y. So we have this one and this one, which is a negative 2e to the negative x plus y. And then last but not least, these two, which would definitely be plus 2 to the negative x minus y. All over 4. But of course, it wouldn't be me if I didn't make a sign error. So this one here should definitely be negative. Which would put this one to be negative. And then when we multiply through, we end up with e to the x plus y. So we end up with x times e to the y, which is e to the x plus y, x times negative. So this would negative. So that puts us at negative e x minus y. Then we end up with e to the negative x positive e to the y. So positive e to the negative x. So that's positive here. And then last but not least, we end up those two, which will be a negative there. All right, so now we need to fix our sign. So that's good. See, I knew a couple things canceled out here. I don't have my notes in front of me. I actually left them at home. So we can actually go ahead and cancel this one with one. And then we would be able to cancel that one with that one. Yeah. And so what we actually end up with is 2e to the x plus y minus 2e to the negative x all over 4. And then the 2's would cancel out. I'm going to have to redo this one over and then... Alright, so we have the following situation, and the goal again here is to go from one side onto the other, and we can easily do so using again the definitions of sine h and cosine h. And when you're looking at identities, you definitely want to start with the more difficult side, which in opinion happens to be the right side. So we'll do that. So sine h of x times cosine h of x plus cosine h of x times sine h of x can be rewritten using their definitions. The definitions being that sine h of x is e to the x minus e to the negative x over 2. So that took this one, and that's rewritten as that. Then cosine h is rewritten as times e to the x plus e to the negative x all over 2. So that's this piece here. Then we have plus cosine h of x. Oh, I definitely forgot that these were y's, not x's. Right, because I definitely didn't write them here either. Okay, so we're just gonna read this one more time. Okay, so we have a left side and a right side. We're trying to figure out whether to go from left to right, right to left. You always want to start a more difficult side, which in my opinion here would be sine h of x, cosine h of y, plus cosine h of x times sine h of y. I'm going to use the definitions of sine h and cosine h to write the expression on the right, and then we will move on and see if anything cancels out. So remember that sine h of x is e to the x minus e to the negative x over 2. So part of the expression is all of this. And we're multiplying that by cosine h of y, which would be plus e to the y all over 2, and that's a negative y here. So this expression can be rewritten as that. And we're adding to that cos h of x, so that's e to the x plus e to the negative x over 2, where cosine is plus and sine is minus. All this happens to be all that. And then we end up with times e to the y minus e to the negative y all over 2. So we rewrote our 4 expression there. And now we can definitely put all of them together. However, I'm going to start with the first 2 and put those together. And then I'm going to put these other 2. See if that helps us. So that would then have e to the x minus e to the negative x times e to the y plus e to the negative y. And we'll just keep working with that. So we'll go ahead and distribute through. So we're going to take e to x times the y. That puts us at, remember that when we're multiplying the same base, we add the exponents. So this would be the x plus y. Then we're going to take e to the x and multiply by e to the negative y. That's going to be plus e to the x minus y. Then we distribute negative x, e to the negative x times e to the y, which would put us at negative e to the negative x plus y. And then last but not least, we take negative e to the x times e to the negative y, which would put us at negative e to negative x minus y. And that is not over 2. That's definitely over 4 because 2 times 2. Alright, so this is over 4. Notice that nothing is canceling out yet, and that's because we still need to figure out what this is going to be, or maybe that will help us cancel stuff out. So in this case, we're taking e to the x plus e to the negative x times e to the y minus e to the negative y. So we take e to the x, e to the y. That's going to be to the x plus y. Then we want to take x times negative e to the negative y. And that's going to be negative the x minus y. Then we want to take e to the negative x times e to the y. So that would be positive e to the negative x plus y. And then last but not least, we'll do x times e to the negative y. And that's going to put us at negative e to the negative x minus. all over 4. And since they're both over 4, we can now rewrite all of these together. And there's a plus sign in the middle, so no signs will be affected. Notice that we end up with e to the x plus y plus e to the x plus y, which is 2e x. We have a positive e x minus y, negative e to the x minus y, and then we have another negative positive, so that'll cancel out, and then we're left with a negative e to the negative x minus y, and another one. So that puts us at negative 2e, negative x minus y. And remember that this can be rewritten as 2e plus y minus 2e to the negative x plus y divided by 4, because I can just pull out a negative from both of these. And why am I doing that? Because again, we're trying to get this. So to finish this off, we have 2's that will cancel out. This 2 cancel out, this 2 cancels out, and this 4 be 2. And that's how with e, the x plus h minus e to the negative x plus h over 2, which is definitely going to be sine h of h. And we're done. We checked the identity. All right, so you'll have a couple of these to do on your assignment. So we did 1, 2. Do one more, and then we'll go on to derivatives. So we're going to prove the identities. So we're going from the left side to the right side, or the right side to the left. In this case, I think it would be a good idea to go from the left. So we're going to start at cotangent h squared of x minus 1. And remember that cotangent h squared would be the same thing as cosine h squared of x over sine h squared of x minus 1. And then the hope is that we end up with cosecant h of x, and cosecant happens to be, and sometimes the idea to figure out what that right side actually happens to be, is going to be 1 over sine h squared of x. Let's see if we don't need to actually use the definitions here. We may need to, but if we start off by just kind of putting these together, so we have sine h over sine h squared of x, we would want to switch 1, so we'll multiply both by sine h squared of x, and that's going to be really nice because sine h of x minus sine h squared can be put together. Now they have the denominator, and using another identity, which is the Pythagorean identity, we know that the top is equal to 1. And we actually definitely end up with 1 over sine h squared of x, which is definitely cosecant squared of cosecant h squared of x. We did it! Okay. That was actually quite nice. Again, the key part here is a fraction. And so I went ahead and multiplied the top and the bottom by sine h squared of x. All right, let's take a look at some derivatives, and then we'll be done with this section. Here you go. Let's find derivative of h of x, which is equal to sine h of x to the 6. Okay, so this is definitely a chain rule. Don't forget that your chain rule is going to be the derivative of the outside with the inside times the derivative of the inside. So let's try it. our outside function. If you still need to do this, you definitely should. Your outside function here is sine x, and your outside function happens to be x. So our derivative, or h prime of x, is going to equal the derivative of sine h of x with x to the 6th, which would be cosine h with x6, and then multiply by derivative of the outside, of the inside, which is going to be 6x. This is really the most I would do here. I mean, you can if your heart desires, but it's really not much else that we can do. And that's that. Let's see what else we have. We have sine h of ln of t, so we have another chain rule here. Here is our outside function. Again, it's still be sine h, and then our inside function happens to be ln of x. I know we're looking at t's, but this is just our side work here. So g prime, or the derivative of g, is going to be the derivative of sine of h with ln of t, which is cosine of h, times the derivative of ln of t, which would be 1 over t. What we done here? Cosine h ln of t all over t. This is as much as I would go through here. Another chain rule. Most of these are going to be chain rule. Here's a chain rule within the chain rule. So you have 7 to the v is your inside. It's inside of tangent of h, which is inside of e. So this is a really nice problem to look at. I'm going to leave that to you guys, so you can definitely practice that chain rule. And that's it for this section, you guys. This is pretty much it. We got the derivatives, and well, you definitely want to commit this to your index cards. I'll be giving you this. However, this is definitely something that I'm going to add to our derivative cheat sheet. Okay, y'all have a wonderful rest of your weekend. I will see you guys on Wednesday.